Okay, so what we talked about yesterday, all right, two periodic trends. We're going to discuss two more today. Okay, we were going to get into the exception today to ionization energy, and I changed my mind on that. We're going to talk about that tomorrow. That I don't know. That might end up being a bonus question. I really haven't decided.
Trends.
Your quiz tomorrow simply asks you to, or requires you to know the trend. So, and we'll go over that quiz here in just a little bit. But the test on Thursday, you need to know the trend and be able to explain the why. Okay. So here's the two trends that we've discussed so far. The first one is that if you go across a period on the periodic table, left to right, atomic radius decreases.
So,
You need an extra periodic table. There's some on the table.
Go grab one, because there's two
Yeah, anytime you need one, just get one. You'll end up with a whole probably dozen.
Hey, Ellie, can I get one? Yay!
wait, so Mr. Kendall.
Oh, goodness.
So much writing in my
So for potassium and krypton, there's a decrease.
Krypton is smaller
I
than
was
that.
grabbing two.
So on potassium's row horizontally, potassium is the biggest one. So iron is bigger than cobalt.
Are there multiple different things like this?
And then when you go down,
Two for atomic radius.
so helium is less than
This is S.
krypton.
Helium is S, right?
Yes.
Helium is smaller than krypton. Yes.
So that's all we need to know.
Well, we gotta explain why. So I gotta know tomorrow.
So, but no, but I can just say why because you said so,
No.
and that's what you taught.
The
middle part is P.
Like, so only a scientific answer.
All right, let's talk about the why. So we've got atomic radius decreases going left to right, increases going top to bottom. Why does it decrease going across a period?
Because the number says so.
Sort of, actually, that's kind of almost right.
What I said?
More electrons and protons will positive and negative attraction will actually.
All right, so
Wait, what?
good answer. Nobody heard the answer but me.
I heard it. I actually heard it.
Great answer.
What was the answer?
Well, we did.
Because the positive and negative charges.
They're talking. I want to hear that. We're trying to learn the answer.
Julia!
I get violent.
This is scary.
All right. So the answer is because of an increased number of protons, right? So the increased numbers of protons and their corresponding electrons attract each other more, and therefore they get a little closer and a little closer to each other the more you have. Take two extremes, neon and lithium. 10 protons, 4 harder than 3 protons. So neon is smaller than lithium. Okay? So when we're talking about atoms and their sizes and a lot of their properties, it is almost never about the size of the particles. It is almost always about their ability to attract or repel each other. Okay? It's by far the most significant thing. So traction causes them to be smaller as you go across. We have a phrase for that term, effective nuclear charge, right? So as you go left to right across any period on the table, there is an increase in effective nuclear charge, which explains why they get smaller and also explains the next thing as to why their ionization energy increases. We'll get back to that in just a second. Yep.
So their effective nuclear charge only increases and then decreases?
Going across, it always increases. Yep.
Okay.
Left to right. No
Okay.
exceptions. All right, now, why does it get larger going down the group? Energy level. So higher energy level means larger orbitals, right? So your energy levels are increasing, so it's going to be larger. Okay. All right. Now, the second trend.
There's another one.
Yeah, there's two more after this one. It's ionization energy, which we can abbreviate IE. Increases going across a period, and decreases going down a group.
So it's the opposite of atomic radius.
Yeah, opposite trend, but for the same reason.
What? Energy.
So ionization energy is the energy required. So it's an energy requirement. I have to think of it that way. It's an energy requirement. Energy required to take the electron away from an atom. Okay, that is more difficult to do as you go left to right across a period. It's easier to do as you go top to bottom down a group. For the same reasons as things get smaller or larger. So the effective nuclear charge, the increasing number of protons, makes the atom smaller, as we just said, and it also makes it harder to remove those electrons. They're more tightly held. So the atom is smaller and harder to take the electron away from. As you go down the group, atoms are larger. Those electrons are further away. So they're easier to remove. The further away from the nucleus they are. Because what's holding them in is the nucleus, those protons in the nucleus. The further you get away from that, the easier it is to get rid of it. Okay. All right, now. Everybody good with that? Oh, let's go back. Let's go back to something else from previous days here right quick.
I get it.
All right, what's that stair-step line separating?
Metals and non-metals.
Okay. Metals and non-metals. All right. Left are the metals, right?
Yes.
The right up here, that's the non-metals.
Correct. Yeah.
The metals are going to do what? Make stable ions.
Lose
They're
electrons.
going to lose electrons, and that makes them be what?
Cations.
Cations. And the non-metals are going to do what? Be stable. They're going to gain, that makes them be what? Right. Who's not going to gain or lose? Noble gases, because they already satisfy the
Octet rule.
octet rule. Very good. Okay. Now,
Yes, you are.
when these metals lose electrons, they become positively charged. Okay. Non-metals become negatively charged. This group's going to make plus ones. This group's going to make plus twos. These make minus ones, minus two, minus three, minus four. The charge and the oxidation state are mathematically and essentially the same thing. The charge is the difference in the number of protons and electrons. The oxidation state is the number of electrons that were gained or lost to make the atom stable. Those are going to turn out to be the same number, okay? But it's written differently. Charge is number sign, oxidation state is sign number, but I'm not going to worry about that, okay? But you do need to know both ideas. They will both be mentioned. Now, we drew some extra boxes here. We have the D block metals, and we have the P block metals. We said that they lose their valence electrons, okay? And then the D blocks can also lose some D electrons. We didn't get into this too much, but sometimes the P doesn't lose all of its valence electrons. They do some weird things too, okay? Point being, though, what we do need to recognize is that these have multiple stable ions and therefore multiple oxidation states. You have to just kind of figure out the possibilities. There are exceptions to that. We did not mention this the other day. Silver is always going to be plus one. That's its only choice. Zinc and cadmium are plus two. And aluminum is plus three. We really need to know that. Okay? Silver is going to be a +1. Zinc and cadmium are going to be +2, and aluminum is +3. So that's sort of exceptions to the exceptions.
Oh, no.
And so both are just with the oxidation state, their charge is still.
This charge would be 1+, 2+, 3+. It still matches up. Okay. So, speaking of forming cations and anions, let's talk about the size of such things. All right. Number one. First fun fact of the day. Cations are smaller than their neutral atom. Number two, anions are larger than their neutral atom. Okay, example. Sodium. Okay. What does a sodium atom do to become stable? Loses that one valence electron, right? Okay. So it goes away, and you end up with sodium 1+ that looks just like neon, right? Now, when it lost that valence electron, losing the actual mass and volume of the electron doesn't mean anything because it's so tiny, it's insignificant. What it lost was two things, one major thing. Major thing that it lost is it lost its entire third outer energy level, right? So we mentioned, I think, if you like peeling an onion before, we mentioned that the other day, how it's kind of a bad example, but sometimes it works. If you had an onion with 3 layers and you peeled off the third layer, your onion is now considerably smaller than it was before, right? Okay. So you're losing an outer energy level. That's the major reason that it's smaller. Another reason that it's smaller is you've lost some of the electron repulsion. So you've got 11 electrons in this atom, right? Those electrons don't like each other. They tolerate each other by occupying separate orbitals, and if they share an orbital with somebody, they spin opposite directions, and the protons are attracted, right? So between the attraction of the protons and the fact that the electrons configure themselves in a way that they can at least tolerate each other, they stay in the atom, but they don't like each other. Okay? If you take one of them out, the others kind of relax a little bit. They sort of kind of just shrink just a little bit. Okay? It's kind of like, don't call names, okay? But if you ever in a group of people and there's one person in the group that nobody likes, do not call names. Okay? All right. But if there's somebody in the group that you don't like, and it's kind of messing up the conversation, you know, like nobody's really talking or saying anything because it's that one person. And that one person gets up and walks away, and everybody else just automatically kind of turns and starts talking together, right? You ever been in that situation? Okay, please don't call names, all right? But that's kind of the idea, right? Kind of the idea. The opposite occurs when you form an anion. So if you take chlorine, for example, okay, chlorine needs to do what? to make itself a stable ion, it needs to gain an electron. So it puts one more right there, and that makes it negative charged. Okay? All right, the problem is you had 17 electrons that are tolerating each other fairly well, okay? But then you throw in number 18, and this is like you're sitting around with that group of friends and everybody's chit-chatting, okay? And here comes this one person that everybody doesn't like, okay? And when they walk in, everybody just kind of goes, you know, kind of walks away, you know? Maybe wants to be around that guy. It's kind of the same thing. When number 18 electron shows up, the rest of them just spread out due to increased electron repulsions. Okay? So, we come back over here.
So if you're losing one, why is it 1+?
Because you lost a negative thing. It's minus and minus. Class. Minus and minus is a plus, right?
Right.
Right.
Yeah.
Think of it another way. This has 11 protons and 11 electrons.
Huh?
This has 11 protons and 10 electrons.
Ah.
So 11 pluses and 10 minuses make. There we go. This had 17 and 17. Now it's got 17 and 18 electrons. So 17 plus and 18 minus makes 1 minus. Because you added a negative,
Right.
which is subtracting. Oh, here you minus the negative, which is adding.
So this is all the charge, right?
Yep.
But would you work out the oxidation state the same way?
Same way.
Okay.
So the oxidation state of this sodium is +1, and this chlorine is -1.
Okay.
They match up. Okay, so we need to know these two facts, just like we need to know the trends, right? Yep.
Okay, so it's kind of like the opposite of what was said over there. So it's like how more electrons would like get smaller. Like so, if you had 10 compared to like helium or 1, they get closer. So it's kind of like the
You had
opposite.
more protons, that makes things smaller. You throw in more electrons, that makes things bigger. Because we
Okay.
kept proton numbers the same. So this had 11 and 11 protons, right? This, let's use this one as better. This had 17, it still got 17 protons. So all we did is we threw in more electrons. So if we're going across a period and adding protons, it'll make things smaller. If you start adding electrons without changing protons, it makes things bigger.
Okay.
All right, now, so let's come up with the why here. So we need to know the facts, just like we have to know the trend, and we have to know why it's a trend. We gotta know these two facts, we gotta know why they're true, okay? So, cations are smaller. Why? Lost energy levels. Okay? Anions are larger. Why? Increased electron to electron repulsion. Okay. Everybody good with that? That covers the things that are on the quiz tomorrow. So before we go to something new, I hold in my hand your quiz from tomorrow. So it's 10 multiple choice questions. That sunshine is glaring on that horribly. That's not helpful. Here. Here we go. All right. 10 multiple choice questions. Okay, number 1. Says which of the following neutral atoms is the largest? The 4 choices come from the same period. Okay, so they're all on the same row of the table. Pick out which one's the largest. Number 2, which of the following neutral atoms is the smallest? Those 4 choices come from the same group. So you look within a group and you have a periodic table at your disposal. Okay, it'll be a blank one that I give you tomorrow, so not the one that you've written all this stuff on. Okay. Number 3, which of the following is the smallest? You have two choices. You have an atom, a neutral atom, and its corresponding stable anion. Number 4, which of the following is the largest? Two choices. A neutral atom and its corresponding stable cation. That's what we just talked about. Number 5, which of the following has the largest ionization energy? And the 4 choices come from the same group. Number largest ionization energy, and you're picking from 4 atoms in the same group. Number 6, which of the following has the smallest ionization energy? And you're picking 4 atoms from the same period. Which of the following atoms is the smallest? These 4 are in the same period. Which of the following is the largest? These 4 are in the same group. Which of the following has the largest ionization energy? 4 atoms from the same period. Which one has the smallest ionization energy? And it's 4 atoms from the same group. So all you got to do tomorrow is know the trends. Okay? 3 things, 3 possibilities here on this. Number 1, you study, you get it all correct, you make 100. Okay? Number 2, you study a little bit, but you get it all backwards. I only say this because I have it happen usually to somebody every year. And they get all the trends backwards in their head, and they make a 0, okay, because they picked the exact right opposite answer from the correct one, okay? So be careful about that. And then option number 3 is you don't study at all, and you get the statistical guessing average of about a 30, which might be better than the person who actually studied but did it all backwards. So, live, you know?
You fail, you don't study, you fail, you study, you pass.
Yeah, there's 2 study options. 1 passes, 1 fails. And then there's the don't study option if you fail. There's not a whole lot in between on this sort of thing. There will be a lot of hundreds tomorrow. And there will sadly might be a few F's. Maybe not. Maybe everybody makes 100. You know, those are the easy ones to grade.
What we just did, like the 1 pluses and 1 minuses, like we don't have to do those.
You just got to tell me which one's bigger or smaller. Tomorrow.
Like
So Thursday will be different.
what?
Thursday will be a different situation. Thursday you're gonna have to explain why things are what they are. Tomorrow you just gotta tell me what they are.
Down the road. Decreases in the
Like the trends,
So that
right?
right there, for what we just talked about there with the anions and cations, right?
Right.
All I'm doing tomorrow is I'm giving you 2 choices. Like for example, number 3 says, which of the following is the smallest? The 2 possible choices are a neutral atom and that element's stable anion. So anions are larger, right? So the atom would be smaller.
So we only have 2 options.
2 choices, multiple choice, 2 things, 2 choices.
So that one's not like specifically like this element is larger than this element. That's just like,
No, this element is larger or smaller than its corresponding stable ion.
So we don't need to know the trends.
Yes, you do need to know the trends. The other 8 questions on the test are about the trends.
Said it's not me.
Atomic radius and ionization.
Okay, but there's 2 of there that's about that.
could we make it do? Could you post some kind of practice quiz? Slightly. Maybe 1 question of each type.
I'm sure Khan Academy has one.
I guarantee Khan Academy's
Is
got
like the
one.
first
I don't guarantee it.
Ionization
Just about guarantee they got one.
increases as more
Oh.
electrons back comes in, right? Where it's closely bonded, but then
Say it again.
ionization energy.
Increases across the period if you have more. Decreases standard groups, those things further.
It's a very efficient. Got it.
All right.
But, it's very inconvenient.
Were you in the?
All right, next trend that is not on tomorrow's quiz. Okay, but will be on Thursday's test.
We're going from which ions?
Because a lot of us say don't call it.
I wonder if the small atoms or the. Up there.
Here we go. Long word. Electronegativity.
Whoa. Whoa.
That's,
How many words much bigger than that?
that's a pretty cool word.
5, 6, 7,
8, 9, 10, 11, 12, 13, 14, 15, 16, 17 letters.
I mean, it's a big word. Not really. Because I just think I didn't expect it to be crazy.
You're crazy.
Big.
Which year on the table was this one?
Electronegativity.
I'm sorry, that, I didn't mean that.
An atom's attraction for electrons in a covalent bond. Okay? An atom's attraction for electrons specifically in a covalent bond. Now, have y'all heard of the term covalent bond? That's when the electrons are shared, right? We will spend several weeks on covalent bonds in a couple of months, okay? For right now, we just need to recognize that we're talking about sharing electrons and that atoms do not share equally, okay? They tug of war over their shared electrons. They don't share evenly. It's going to be very important for us to know in the following units which one is pulling harder than the other one, who's winning the tug of war. That's a very important thing to know. Okay. Maybe. All right. So there's a trend on the periodic table. Here we go. All right. Going across the period. Electronegativity, all 17 letters, which I'm still kind of impressed by that. Anyway,
Decreases.
increase.
Dang it, that's
False.
Going down a group. Electronegativity decreases. All right, now, so based on that trend, we got to know this, okay? Fluorine is the #1 most electronegative element on the table. Oxygen is #2. Chlorine is #3. We need to know 1, 2, 3. Fluorine, oxygen, chlorine, 1, 2, 3. Now, question. Those starting to catch on to this chemistry thing here a little bit. If the trend is that it increases going left to right, bottom to top, why is helium or neon not in the top 3?
Because they're noble gases.
Because they're noble gases, which means what?
Which means
satisfy the
Yes, which means they don't do what?
They don't do the chemistry.
They're looking at the definition of electronegativity. What
They
we
don't,
use them out. They don't make covalent bonds, so they don't meet the definition. Okay, so we ignore the noble gases when we're talking about electronegativity. We do not ignore them on everything else. I've had students in the past who got that confused. Okay, we don't ignore the noble gases when we're talking about size of an atom or ionization energy or anything else. But we do ignore them when we're talking about electronegativity because they don't meet the definition. All right, so they're not going to at least naturally make any covalent bonds. So we're not interested in their ability to attract electrons in a covalent bond when we're never going to have them in there. Say never until we actually have acceptance, so that's later on. So fluorine's number 1, oxygen number 2, chlorine number 3. Who's going to be the least electronegative? The other end of the list. Somebody said
Rhodium.
Francium.
Oh.
Francium will be the least electronegative.
Right.
How much time have I got?
4 minutes.
4 minutes? 3 minutes? Good. I got one more thing. Okay, last thing for today. And to do this one, we're going to need our stair-step line.
Oh,
Okay,
gross.
because this is kind of a double trend. Okay, there is a trend for the metals and a trend for the non-metals, and they're different. So for the metals, reactivity, this is what we're talking about here, is how reactive they are. For the metals, francium is the most reactive metal. So reactivity increases going down and to the left. So I know my periodic table's getting kind of crowded here. So for metals, reactivity increases left and down. That makes francium the most reactive metal. For non-metals, it's the opposite. Non-metals, their reactivity increases going up and to the right. You'll see what I'm writing here. Reactivity increases. On right and up. So fluorine is the most reactive non-metal. Again, we'll skip noble gases with that because they don't react. Okay. Electronegativity and reactivity are not on the quiz tomorrow. We will discuss them again after the quiz. The quiz should take about 2 minutes tomorrow, okay? And then we'll talk some more about the whys. We're going to take a quick look at the exceptions to ionization energy tomorrow, and then test on Thursday. I do.